Hello everyone, I am Soumyashree Senapati, Assistant Professor of Civil Engineering, Vedang Institute of Technology. So, in this class, we will discuss one numerical on member subjected to biaxial stress, application of biaxial stress, but using Mohr circle method. We can solve it using analytical method, but here we will solve this with Mohr circle method. So, first, what are the given data here? Here we have biaxial stresses, like one is maximum stress, here maximum stress, and another one is minimum stress. So, we can see the whole stresses applying here in tensile direction. Okay. So, we can take sigma x as 100 megapascal and sigma y as 50 megapascal. Okay. So, angle is given, that is 30 degree. Okay. Here you can see this angle is acting anticlockwise direction. Okay. Now we have the given data, now we need to solve it and find out what normal stresses and tangential stress. So, first we need to just draw, right, and here we have the x and y axes. So, this is your what? Normal stress axis, and y axis represents shear stress, that is tau. Okay. So, first what we need to draw? We need to find out this 100 megapascal. So, here we have O, or name it as a O. Okay. So, we will have 10 scales, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Here we can take 100 megapascal. Okay. Let name it as S. Right. So, another one is, we have already done 100 megapascal. Next one is to 50 megapascal. That will be 1, 2, 3, 4, 5. Here. That is sigma y is equals to 50 megapascal. Right. And another one is 100 megapascal up to this. Okay. Here. So, we have sigma x and sigma y. Okay. Now what? Now our work is to find out sigma x plus sigma y upon 2. So, here sigma x plus sigma y by 2, that will be 100 plus 50 by 2, that is 150 upon 2. $75 we will have here, like 1, 2, 3, 4, 5, 6, 7. Here we will have that point. Okay. So, this 7.5 we will take let as Q, right. So, now from this point to this point, we will draw the Mohr circle diagram. Here we have the smallest Mohr circle, I think. So, we will draw the Mohr circle. Now, here as let this point as S, and here we can take, okay. So for the point sigma y, we will take that as P. So OP is sigma y and OS as sigma x. So till now we know what is sigma x and sigma y. Next our work is to find out, I have already said that if the angle is 30 degree, we need to take that angle in Mohr circle, that is 2 into 30 degree. We will take 60 degree. So here we have the point. We can say that angle is in anticlockwise direction. So we will have the 60 degree in that manner. Okay, here we have 60 degree. So here let this point as T. So from T to we will draw one what? We will draw one perpendicular up to this point and let name it as M. So we have the Tm as nothing but our tangential stress. Let it will be 50 meter. If we just draw this diagram using AutoCAD, we will automatically find the perfect diagram. Okay. So from this point, okay, from this point to this point is nothing but our sigma n, right? So it will be as it is of in between 75, 80 and 90, let it is as 85. Okay, 85 megapascal. So what is the difference here? Like we have 100, we have taken 100 megapascal as 10 units. Okay, we have 10 units. So 50 megapascal is what? 5 unit. Okay, so like this we have the sigma n and sigma t values. Another thing is what? We need to find out this to this, that is nothing but our sigma r, that is resultant stress. Okay, so this resultant stress is nothing but sigma r will be root over of sigma n square plus sigma t square. Okay, so in this way, if we solve in Mohr circle method, we will have the values like this. Okay, and we have here what? Sigma n, sigma t and sigma r. So here this is the method for case 1. Another thing is what? Our case 2. Here you can see we have used anti-clockwise direction angle. So if this angle will be at clockwise direction, what we will do? What another thing we will do was here. Okay, if there is the question like if the angle is clockwise direction to the vertical, the angle is clockwise direction to the vertical. So in that case we have taken the angle here in this manner. Okay, and like this. So that is for anti-clockwise. If the question asked to clockwise direction, we will draw the angle in this way. Okay. So what changes will occur in case of Mohr circle? Let's see. So let this is our x-axis and here we have the y-axis. So, okay. Here we have x-axis and y-axis, that is sigma representation for normal stress, and here we will have tau. So, you can see we have the normal stresses in x direction only, and we have the shear stress in vertical axis, or you can say y-axis. So, first what we will do? We need to draw sigma x and sigma y. Sigma x is what? 100 megapascal and sigma y is 50 megapascal. Let 100 megapascal is up to here. Sigma x is equals to 100 megapascal. Okay. Another thing, that is 50 megapascal up to this. Okay, that is our sigma y. So, what we need to do? The same process, but there will be little bit change. Okay, we will calculate sigma x plus sigma y by 2 and we will have 75. So, this is the midpoint. Let's draw the Mohr circle. Okay. So, what next? We have the midpoint here. So, as that is said that the angle is acting in which direction? In clockwise direction. So, this is our P and this is Q. So, this PQ plane is mostly important. Okay. So, if this is acting in clockwise direction, you can see like in this direction. So, what? The angle will be from this plane to 60 degree, like this. So, there will be nothing change, more change, only change is direction. If it is in anticlockwise, so we will draw the diagram in positive side, and if it is in clockwise direction, we will draw in negative side. Okay. So, here the angle is nothing but 60 degree, because I have already said that in case of Mohr circle, it will be 30 degree into 2, that is 60 degree, right. So, another processes are very similar to the first one. We will draw the perpendicular diagram and let's name it as what? T. So, this Tm is your tangential stress or sigma T, or you can say tau. Okay. And here from these two, this is your sigma n. Okay. You need to just remember thing like in case of clockwise direction, we will draw the diagram below the x-axis, and if it is in anticlockwise direction, we will draw the diagram above the x-axis, right. So, we have sigma n and sigma t. By that, so here we will have the resultant stress from this direction, like this. Okay. Here we have sigma r. Sigma r is nothing but root over of sigma n square plus sigma t square. Now, let us put the values. Okay, sigma n and sigma t we already have. Let us put it, and we can recheck it by cross checking this to this distance and with this. Okay, so here we have already solved the method or the numerical by using both the angle in clockwise direction and anti-clockwise direction. So, in our next numerical, we will solve this method by using tensile force and compressive force both. So, there will be little bit differences. To know those differences, you need to stay tuned with the channel. So, keep smiling and keep shining. Thank you so much.